Good morning, ma'am. This is semester 5 PBL project and our topic is RGB LED temperature indicator. This is group number 7 and group members are Nilesh Gaikwad, Rahul Gaikwad, Chaitanya Gawande and myself Omkar Gokhale. This project is guided by Professor DP Poddar ma'am. So first of all, the introduction of this project. So in this project, the LED will change color from blue to cyan to green to yellow to magenta to red depending on the temperature of the surrounding environment. With blue indication very cold and red indication very hot. Different temperature ranges will produce a different color LED. Blue is used for very cold indoor temperature, indicated for temperature below 16 degrees, followed by cyan, green, yellow, magenta, and then red. For about 31 degree, or we can set it a temperature. When the temperature sensor is touched, the color changes to magenta or red depending on the body temperature. This is the image of our temperature indicator. Now I hand over to my friend Chaitanya for further explanation.
Thanks, Omkar. The components which we are using for these projects are Arduino, RGB LED light, 300 ohm resistors, temperature sensor, which is a TMP36, which we are using here, connecting wires, one breadboard, and the next one is the circuit diagram. Here the circuit diagram representation is there. One Arduino is there, 300 ohm resistor are connected to breadboard, one LED light, and one black temperature sensor is there. That is TMP36. This next one is a prototype of our project. And next slide is assembly of components. The connecting wires of Arduino power to the breadboard, both the temperature sensor and the RGB LED would require to be connected to the common ground and 3.3 volt. So we will use the breadboard power rails. Connect the 3.3 3 volt pin from the Arduino to the red power rail on the breadboard with the red cable. Connect the ground pin from the Arduino the black power rail on the breadboard with a black cable. Next one is now wiring the temperature sensor to the Arduino. Connect the bottommost pin of the temperature sensor with the flat side facing right to 3.3 volt on the red power rail of the breadboard. Connect the topmost pin of the temperature sensor to the common ground on the black power rail of the breadboard. Connect the middle pin of the analog pin A0 of the Arduino. Lastly, the wiring RGB LED to the Arduino. Connect the longest pin of the RGB LED to the common ground on the black power rail of the breadboard. Then connect each of the three other pins from the pin on the edge closest to the ground. This is the red LED pin to 100 ohm resistor in series to pin 5, 6, and 9 on the Arduino respectively. Next slide is source code represented by my friend Omkar.
So the source code is a very important part of this project. So I added the double slashed lines, that is the comments, which is to understand the specific part of the code. So I'm explaining. So first of all, this is to create the constant for 3 analog input pins, and second, this is here we created the constant for 3 RGB pulse width pins. Now in this we have to create variables. So this code is to create the variables to store the red, green and blue values. Now we will set the RGB pins as output by using this code. And now here we are creating a function. Here we are creating the function which is set up in this. We are setting the RGB pins as output, and here we are creating a function called loop. Now in this, it is to make the system read the 3 analog input pins and store their value to the color variables. After this, we will use the map function to scale the 10-bit analog input value to an 8-bit PWM, which is pulse width modulation. Then store the new mapped value back into the color variable, which we defined here. Now after this, we will use the analog write function to write the color value to their respective RGB pins, which is red pin and we are setting the red well, which is here, and this is the value of the red well. So we are uh, assigning the value to the red pin, same with the green pin and with the blue pin. Now here is the if else condition. This is used to change the color according to the condition of the temperature. So here is when the temperature is less than 16 degree, we want blue color. So we will make the blue pin on, which is we do by writing high. Second is less than 20 degree. So we want the color sign, which makes when blue and green mix. So blue is already up on, and we will on green here. After this less than 25, which makes we want green, so we will turn off blue pin. After this less than 32, which is warmer, so we want yellow, and it is a mixture of green and red, so we will turn on red because blue is all green is already on here. Same with 38, less than 38 magenta. Here is red and blue mixture. We will turn on blue pin, and green pin we will low. And after that red, so we will turn on blue pin. After that, I hand over to my friend Nilesh for the uses of this temperature indicator.
Thank you, Omkar. I will explain the uses of the building. The temperature we use in doors, furnace, and other technical equipment in the laboratories and in the product. Important to be aware of changes in temperature to monitor and maintain the temperature of the raw materials and the finish the product during the storage and temperature to protect from the temperature changes. Okay.
Thank you. And now after this, there is a small video of our temperature indicator, which I'm playing right now. So as you can see, when we touch the indicator, it turns to magenta because of our body temperature, and then red because of the room temperature. So that's all from our side. Thank you, ma'am.